6.3 Measures of central tendency for group data. Recall, the measures of central tendency are value which is representative of a set of data. The measures of central tendency involve calculating of mean, median, and mode. Now let's look at how to find the means or X-bar for the group data. The formula for the means of a frequency distributions can also be used to provide an estimate of the sample mean of a set of group data. The formula is X bar equal to summations of fx divided by summations of f, where summations of fx is the summations of frequency times midpoint for each class, and summations of f is the total frequency or observations n. Next, let's look at how to find the mode or capital M for group data. So, the mode of a group data can be found by using formula. The formula is given by M equal to Lm plus in the bracket D1 divided by D1 plus D2 times C, where Lm is the lower boundary of model class. D1 is the difference between frequency of model class and the class before. D2, difference between frequency of model class and the class after. C, width of the model class. And you must know that the model class is determined by the highest frequency among the class intervals. Next, let's look at how to find the median or small m for group data. The median is the middle value, which implies that 50% of the value are less than or equal to the medians. M equal to Lm plus n divided by 2 minus capital F m minus 1 divided by small fm times C, where Lm is the lower boundary of median class. Capital F m minus 1 is the cumulative frequency of classes before median class. Small fm is the frequency of median class. N is the total frequency or observation summations of f. C is the width of the median class. You must know that the median class is determined from the location's middle observations among the class intervals. Example 7. Data obtained from the speed limits of vehicles at a particular area on the Plus Highway during the recent festival season is given below. The speed in km per hour and the number of vehicles. For the first class, the speed is 90 until 95 km per hour with the number of vehicles are 12. For the second class, 96 until 101 km per hour with the number of vehicles 4. Next, 102 until 107 km per hour with number of vehicles 19. Next, the speed is 108 until 113 km per hour with the number of vehicles 35. Next, 114 until 119 km per hour with the number of vehicles 26. For the last class, the speed is 120 until 125 km per hour with the number of vehicles are 14. So, based on the above informations, number 1, calculate the mean, median, and mode for the speed limits of the vehicles, rounded the speed limit to the nearest kilometer. Then, interpret the answer. Number 2, hence find the skewness of these distributions. Before we can answer number 1, let's try to recall the formula for means, medians, and mode. So, the formula for the means is X bar equal to summations of fx divided by summations of f. And the formula for the medians is m equal to Lm plus in the bracket n divided by 2 minus f m minus 1 over fm times c. And the last one, let's recall the formula for the mode, which is m equal to Lm plus in the bracket d1 divided by d1 plus d2 times c. Based on the formula of mean, median, and mode, you must expand the table to find the certain informations. You can expand the table to get the cumulative frequency, the midpoint, and fx. So first, let's find the cumulative frequency of each class. For the first class, the cumulative frequency we can get from the frequency here is 12. For the second class, the cumulative frequency is, you can take 12 plus 4 equal to 16. Okay, for the third class, the cumulative frequency will be 16 plus 19, which is 35. And next, 70, 96, and for the last class is 110. For the midpoint, we can find the midpoint of the first class by taking 90 plus 95 divided by 2, which is 92.5. We can repeat the process. For the second class, the midpoint is 98.5. The third class, 104.5. Next, 110.5, 116.5, and for the last class, 122.5. Next, we want to find fx, but we just need summations of fx. So you can find summations of fx by using calculator, which is you should get 12,101. Still on question 1, let's try to calculate the mean. So to calculate the means, we should know this formula, x bar equal to summations of fx divided by summations of f, where define summations of fx, which is 12,101, and summations of f is 110. We can substitute these two informations in this formula. 12,101 divided by 110, you should get 110 km per hour after we rounded the speed limit to the nearest kilometer. Then you must interpret the answer. To interpret the mean, we can say that therefore the average speed limit of vehicles at a particular area on the plus highway is 110 km per hour. Okay, next we try to find the medians. Okay, how to find the medians? We will use the formula m equal to Lm, the lower boundary of the median class, plus the bracket n, which is the total frequency, divided by 2 minus capital F n minus 1, which is the cumulative frequency of the class before median class, divided by Fm, the frequency of median class, times C, the class size. So before that, we must find the median class. So how to find the median class is we must determine from the locations middle observations among the class interval. So to find the middle observation, we must use the cumulative frequency, which is 12 for the first class, 16 for the second class, 35 for the third class, we have 17 for the fourth class, 19.6 for the next class, and the last class 110. So the middle observations, how to find it is by taking summations of f divided by 2. So summations of f is 110 divided by 2, which is, we know that 55th observation. So 55th observations is in here. Okay, so the median class is 108 until 113 km per hour. Okay, next we can find the other informations, which is we can have lower boundary of the median class by taking 107 plus 108 divided by 2, which is 107.5. Next, we can find n, which is equal to summations of f, which is 110. We can find fm minus 1, which is the cumulative frequency before median class. So this is the cumulative frequency before median class, 35. And then we can have frequency of the median class, which is 35. And we can have the class size. So to find the class size, we can take the upper boundary of the median class minus the lower boundary of the median class. So the upper boundary of the median class is 113.5 minus the lower boundary of the median class is 107.5. So you can calculate equal to 6. Okay, now we can substitute the informations we already get in the formula of median. So the lower boundary is 107.5 plus n, which is 110 divided by 2 minus the cumulative frequency before median class, 35, divided by frequency of the median class, 35, times the class size, which is 6. So you will get 111 km per hour after we rounded the speed limit to the nearest kilometer. Now we can interpret the answer. So interpretations for medians is 50% of the vehicles have the speed limit at least 111 km per hour. Okay, now let's find mode. Okay, to find mode, we will use the formula m equal to Lm, the lower boundary of the model class, plus in the bracket d1, the difference between frequency of model class and the class before, divided by d1 plus d2. d2 is the difference between frequency of model class and the class after, times c, which is the class size. Before that, we must find the model class. So to find the model class, we must know the highest frequency among the class interval. So the highest frequency is 35. So we can say that the model class is 108 until 113 km per hour. Next, let's find the information needed, which is Lm, the lower boundary of the model class, which is you can take 107 plus 108 divided by 2, which is 107.5. Okay, next, d1s. Okay, the difference between frequency of the model class, which is 35, minus the frequency of the class before, which is 19 equal to 16. Okay, D2, we can take the frequency of the model class 35 minus the frequency of the class after, which is 26. So the answer is 9, and the class size we already calculated before, which is 6. So you can substitute the information in this formula. We have 107.5 plus, in the bracket, 16 divided by 16 plus 9 times 6. So the answer is 111 km per hour after you rounded the speed limit to the nearest kilometer. Now we can interpret the answer. So the interpretations for the mode is, therefore, most of the speed limit of vehicles at a particular area is 111 km per hour. Number 2, hence comment on the skewness of these distributions. Before we can comment on the skewness, we must recall the value of mean, medians, and mode. So we already get mean 110 km per hour. For median and mode, we get the similar value, which is 111 km per hour. So it's enough to compare mean and mode. So we have the value of means less than mode. Since mean less than mode, we can say that the distribution is negatively skewed. Example 8. The table below shows the expenses in fuels on September 2015 for a sample of 120 workers. So we have expenses in fuels in RMs and the cumulative frequency, which is capital F. Okay, question A, construct a frequency distributions table for the above distributions. B, calculate the mean, medians, and mode for the above data and interpret the answer. Hence, describe the shape of distributions of the data. Okay, now let's look at question A. Construct a frequency distributions table. So, to construct frequency distributions table, we must have class, cumulative frequency, midpoints, frequency, and fx, which is the frequency times midpoint. So for the class, we can copy from the expenses in fuels, which is for the first class, we have x greater than equal to 130 less than 140. Second class, x greater than equal to 140 less than 150. The next class, x greater than equal to 150 less than 160. The next class, x greater than equal to 160 less than 170. Next class, we have x greater than equal to 170 less than 180. The next class, x greater than equal to 180 less than 190. X greater than equal to 190 less than 200. Next class, we have x greater than equal to 200 and less than 210. For the last class, x greater than equal to 210 less than 220. Okay, now for the cumulative frequency, we we can copy from this table, which is for the first class, to the next class, 9 and so on, which is 20, 33, 54, 81, 98, 112, 120 for the last class. Okay, next we must find the midpoint. Okay, let's find the midpoint of the first class. So to find the midpoint of the first class, we can take 130 plus 140 divided by 2. So you should get 135. Okay, for the second class, the midpoint you can take 140 plus 150 divided by 2, which is we will get 145, and you can repeat the process. We will get 155, 165, 175, 185, 195, 205, and for the last class the midpoint is 210. Okay, next we must find the frequency of each class. So for the first class, the frequency you can take from the cumulative frequency here is 2. For the second class, to find the frequency, we will take 9 minus 2. We will get 7. For the third class, the frequency is we will take from 20 minus 9, which is 11. So we can repeat the process. We will get 13, 21, 27, 17, 14, and the last class, the frequency is 8. So you can find the summations of frequency by adding the frequency, which is you will get 120, or you can refer to the last class here, which is the cumulative frequency is 120. Okay, the last one we must find fx. Okay, we just need to find the summations of fx, so you can use the calculator to find the summations of fx, which is you must get 21,670. Okay, now let's look at questions B. Okay, let's find the mean. Okay, to find the mean, we will use the formula x bar equal to summations of fx divided by summations of f. Before this, we already find the summations of fx and summations of f. So you can just substitute in the formula. So we have, for summations of fx is 21,670 divided by summations of f, which is 120. So we get RM 180.58. Next, we must interpret the answer. So to interpret the mean, therefore the average expenses in fuels is RM 180.58. Okay, still on questions B. Next, let's try to find the median. So to find the median, we must use this formula. M equal to LM plus in the bracket N divided by 2 minus F M minus 1 divided by FM times C. So before that, we must find the median class. To find the median class, we must find the middle observations among the class interval. So the middle observations we can take from summations of f divided by 2. Summations of f just now we get 120. So divided by 2 equal to 60 observations. So we can refer to the cumulative frequency. So the 60 observation is around here. So we can say the median class is x greater than equal to 180 less than 190. Next, we must find a few informations before we can substitute into the median formula. So first, you must find Ln, the lower boundary of the median class, which is we can take from 180 plus 180 divided by 2. So the value is 180. Next, the value of n, which is equal to summations of f, which is 120. Next information is Fm minus 1 is the cumulative frequency before the median class. So before median class, the cumulative frequency is 54. We want to find Fm, which is the frequency of the median class, which is 27. And we need to find C, the class size. So we can take the upper boundary of the median class minus the lower boundary of the median class, which is 190 minus 180, so you get 10. Now we can substitute the informations in this formula. We have 180 plus, in the bracket, 120 divided by 2 minus 54 divided by 27 times 10. So you will get the answer Rm 198.89 cents. Next, we need to interpret the answer. Therefore, 50% of the worker spend at least Rm 198.89 in the fuels. Okay, still on question B. Next, let's find mode. To find mode, we will use this formula. M equal to Lm plus, in the bracket, d1 divided by d1 plus d2 times C. Before that, you must find the model class. To find the model class, we can determine by the highest frequency among the class interval. So, check the frequency. The highest frequency is 27. So we know that the model class is x greater than equal to 180 less than 190. Okay, next we must find a few more informations before we can substitute into the mode formula. So we must find Lm, which is the lower boundary of the model class. So to find the lower boundary of the model class, we can take 180 plus 180 divided by 2, which is 180. Okay, next we must find D, the difference between the frequency of the model class, which is 27, we must minus the frequency of the class before 21. So 27 minus 21, you get 6. Next, we must find D2. Okay, to find D2, which is we must have the frequency of the model class 27 minus the frequency of the class after, which is 17. So the answer is 10. Last, we must find the class size, already find before. Okay, so C is 10. Now you can substitute these informations in the mode formula. So we have 180 plus, in the bracket, 6 divided by 6 plus 10 times 10. So the answer is RM183.75 cent. Next, we must interpret the answer. Okay, to interpret the mode, we can say that most of the 120 workers spend RM183.75 cent in fuel on September 2015. We're still on questions B. We just find mean, medians, modes. Then the question asks you to describe the shape of distributions of the data based on mean, medians, and mode. So first, we must recall the value of mean, medians, and mode. Based on the value here, we can compare mean and mode. So mean is less than mode. Therefore, we can say that the distributions of the data is negatively skewed.